In Calc 2, you likely learned that the quantity work is defined like this. The work done in moving an object through a distance d by applying a constant force in the direction of motion is work is equal to force times distance, F times d, where F is the magnitude of the force. Well, I want to evolve this idea. Maybe we have the situation of a box sliding up a hill, right, where here I have a displacement vector. So my object starts here and ends there. And if I think about it, the length of that vector, literally how far I'm moving, and F is a constant force vector. Well, if I think about this just a little bit, I can translate this situation to this situation by imagining the amount of force applied in the direction of motion. The magnitude of this vector, well, and that vector would be the projection of F onto vector D. The magnitude of that vector would be my effective force in moving the object up the inclined plane up this hill, and then the magnitude of the displacement vector would be the distance I've moved through. So I would say the work would be equal to the magnitude of the projection of D onto F times the length of D. Well, and I remember from my last video how to actually find this magnitude, and this might be a good place for you to actually pause the video and write down from our last video what the projection of F onto D is. Okay, and so just remembering that, right, this would be F dot D over the magnitude of D. That would be the magnitude of that projection times the magnitude of D, and we get to cancel those out. We find out the work is simply a dot product. So here we go. The work done by a constant force, F, acting through a displacement, D, is the work is force dot displacement. And I can calculate that without knowing the angle between them. But if I was given only magnitudes, right? Maybe someone gave me the amount of force and the total displacement I moved and the angle between them, I could calculate work using the other definition of dot product, my alternate idea.